These are the various density functions and corresponding distribution functions we have studied. Okay. So the description goes like this. A random variable x is said to have Gaussian density function, or a random variable x is Gaussian distributed. Okay, whenever we say a random variable is dash distributed, it implies that it is the density function of the random variable that is being considered. Is it clear? So if a random variable we come across with certain kind of density function, what inferences can we make? That also we have seen in the previous class. The moment we are given the expression for probability density function, what are the steps we have carried out? Whether it is a valid density function or not. That is what we have verified. We computed area under that density function. If the area under the density function comes out to be 1, we concluded that it is a valid probability density function. Okay. The second thing we did is we tried to take the derivative of that density function and equate it to 0 to know at what value of the random variable the density function is taking maximum value. That is another thing we have carried out. The third thing we have carried out is we have integrated the density function up to certain value of x to compute the distribution function. Okay. These are the things we have performed on a given density function in the previous class. Today what we consider is a few problems we try to solve, and we try to further consolidate our understanding of random variable. So let me repeat again the basics. An experiment is said to be random. I am using the term experiment. When do we say that the experiment is random? When the outcome is unpredictable. An experiment is said to be deterministic if the outcome is predictable. So all our laboratory experiments, they come under predictable experiments. Okay. Suppose you are doing research and you have some expected outcome, but it may not be true all the time. So there is randomness in that. The reason being that in a random experiment, probably we do not know all the factors that influence the process. Okay. When we consider the behavior of a person, is it a random phenomena or a deterministic phenomena? Please respond. We say
Sir,
only
in
two
some
possibilities, random or deterministic. Okay, please.
sir, in some cases it is deterministic, sir. In some
Okay,
cases it is random.
some
Means like
cases. Okay.
sir, in the case of family we can determine, sir, means
Hmm. Okay. Typically, typically in family it is deterministic. Then with outside people it is random, right?
yes, sir.
Any other viewpoint, please?
So depending on the conditions, we can determine in some cases, but there is also randomness in that. Yeah,
Determinism is there, randomness is there, right? So based on conditions, what would be the conditions?
like hitting him or something like that.
Hmm? Please
Having
repeat.
a fight, something like that.
No, typically you said one case. What is that?
Like having a fight with him or something like that.
Having? No, I am not.
Having a, having a fight, sir. Having a fight.
Fight.
Yeah.
Do you mean FIGHT?
Uh, yes, sir. Yes, sir. Means
Okay.
we can
Okay.
determine he's angry,
Okay.
something like that.
Yes.
Yeah.
Yeah. Okay. Misunderstanding. Okay.
Yes.
Okay. So, um, okay. In UHV, you were told that every human being wants to happy. Every human being wants to be happy, and every human being wants to make others happy. Is it true? Yes or no? If that is the
Yes.
case, every individual, right? Then where the randomness is coming from? If that is the case, there should not be randomness. The randomness is coming because of what is that competency. Everybody wants to make himself happy. This is very much there, but he doesn't care for other person. Why? Because he missed a few basic things. Missed a few basic and important things. Yes or no? So for that, what is being said? Every person should have samadhan. What does it? Why and how? Then after that, every family should have samruddhi or prosperity. Then families make up society. So in society, we should have abhay. What is abhay? Fearlessness. Then in nature, we have coexistence. Okay. So whatever we do, now I will spend a few minutes on this so that good concept will come out of this. Um, I lost. Okay. Okay. I will write. Uh, every individual should have samatha. Why to do this? How to do? You are attending the class. You are very much convinced why you should attend the class and with what preparation you should attend the class. That is at your level. At every individual. Okay. At family level, there should be prosperity. What does it mean? Samruddhi should be there. So prosperity, how does the samadhan lead to prosperity? In the family, if everyone is clear about the total work
Yeah.
in the family and the division of the work in the family, then everybody will do his or her part effectively, and that leads to work division. Okay, when the work is evenly distributed among the people, then there will be prosperity. Prosperity means everyone will do their part, so the family becomes rich and they can buy whatever they like. Then the next level is society. In society, there should be fearlessness. When every family in the society is prosperous, there is no question of accumulating wealth, there is no accumulation, there is no misbehavior, because everyone is clear about his role. If there is fearlessness, at the level of nature, we have coexistence with nature. Okay, this is called deterministic behavior. Okay, now just you imagine if our attitude is not related based upon samadhan. I do not know what I am doing. Okay, and I don't consider every decision of mine in the family level, at the family level, and each family doesn't consider about other families in the society. If that is the scenario, there is no abhayam. That means fearlessness. There is everywhere, every time we start fearing about so many issues. Okay, so if everyone follows this samadhan, every family follows this prosperity, every society follows fearlessness, and at nature level, if we ensure coexistence, then it implies that we are at what level? We are living in a society where, okay, the things happen in a deterministic way. The reason being the presence of four things: samadhan, samruddhi or prosperity, then fearlessness or abhay, here abhay, then coexistence. Because most of the persons do not follow these four values, then there is randomness in the responses. Okay, so if you have a work and that is to be carried out, if you take the help of your brother, if the brother is aware of this samruddhi, prosperity, then fearlessness, then coexistence concept, okay, he immediately obliges your request, or he may say that he will do it at an appropriate time. Yes or no? The same is true when he approaches you with some work. When this kind of behavior is ensured in every individual, then there is no randomness in the response of the individuals. So this concept is with reference to an experiment coming under random case. So life is also can become deterministic if life is based upon certain basic concepts. Is it fine? Any questions, please? The very purpose of this PHV class is to make sure that everyone lives based upon certain principles, basic principles, so that our life becomes deterministic, and that deterministic model is leading to or promises happiness to everyone. Okay, so life becomes a deterministic model or random model just because the principles we follow. Okay. Now, most of the time, people follow three hit law. See, I am putting down the Hindi words, right? Let me write down the appropriate Hindi words so that things become clear to you. Okay. Everyone knows Hindi, right? That is the assumption I have. Three hit law. Okay. These are the three issues. Pre means what is interesting. Only I do those things. Hit means what is comfortable to me. Only those things I will do. What is Probably love means helping me, or from monetary point of view, from the point of view of things. Here also, I consider only things which are helpful to me. Okay. If I ask someone to do this work, first he will think, is it convenient for him? Is it interesting to him? Or is it comfortable to him? Or does he gain anything out of this? So most of the time human beings are following this pattern. That's why there is unrest in the individuals as well as in the family. Please check in your life, in your family. If this is happening, please correct the system. Is it okay? Once we know that people are running based on these 3 points, then the next thing we need to do is introspect. Let us introspect. If such attitudes are in me, let me get rid of those things. Why I should get rid of those things? For better life. Is it okay? And these 3 things are required to some extent, to the extent that I need to study well because I have to have a good job to earn my livelihood. That is required. So, to that extent, you can have these 3 concepts to some extent. Okay. But in a larger concept, you should follow whatever decision you take. Is it helpful to me? Is it helpful to my family? Is it helpful to society? Is it helpful to the coexistence in the nature? Plastic, it is doesn't help ensure coexistence with nature, right? So I hope the message is clear. The message is that if we live based on certain basic principles, then our behavior or our life in the society becomes quite deterministic, and that deterministic model promises a healthy, happy living, and UHV aims at introducing that level. Okay, so I am discussing experiment, random, and deterministic, right? We are concerned with random experiment. The reason is we are trying to model a um, random phenomenon. Under random experiment, we have defined a few things. What are the things? Sample space, event, and so on, right? Then, in a random experiment, the outcome can be numerical or non-numerical. If the outcome is not numerical, we map that outcome to numerical value. And we call that by a name random variable. Now, I have a random variable x taking values. What does this mean? It implies that I am considering an experiment where the outcomes are mapped to these 3 values. Once I introduce the concept of random variable, underlying experiment is not known. This is very important. We are not concerned about the underlying experiment. In the examples that we discuss, we are trying to bring the correlation between a practical situation, all the problems that appear in the textbook that connects a practical problem with concept of random variable, probability density function, and so on. Is it okay? Any questions till now, please? I just try to connect the UHV concept with our subject. If that is okay, then I will consider the example. I am reading from the textbook. Okay. What is the page number, please? If you can read. Page is 60. Okay. So in page number 60, Example 2.5-3. Okay. Okay, let me maximize the window. Okay. If I maximize the window, then what this problem says is how to compute um, the median of the random variable. That is the aim of the problem. Okay. So the discussion is around um, the Rayleigh density function to start with. So let me expand this window. Somehow I'm unable. Okay. Script is not visible to me also. Okay. I will read out. Okay. How to determine the median of the random variable. The median of the random variable is indicated by x naught. As shown in this problem, the median is indicated by x naught. By median value, what we mean is it is that value of the random variable x naught such that the probability that the random variable takes a value less than or equal to that value x naught is equal to the probability that the random variable takes a value greater than x naught. That is what this example says. If I say that the random variable is described by, say, Rayleigh density function, if I want to find the median of that random variable, I need to consider that probability of x taking a value less than or equal to x naught being equal to random variable taking the value x greater than x naught. So to find the median, the probability that x takes a value less than or equal to x naught is same as the probability that x takes a value greater than x naught. So from the left hand side quantity, we can write that it is nothing but the value of the density function up to x naught, and that value should be equal to half. So to compute the median of a random variable, median of a random variable, what I need to do? I need to consider the distribution function of that random variable. In that distribution function, I need to substitute x naught, and x naught is the median. For Rayleigh density function, let us see how do we compute a random variable described by Rayleigh density function. What is the median of that? Now we need to write down the expression for the distribution function of Rayleigh density function. So if you have the notes with you or textbook, please try to see the distribution function description for density function as well as distribution. Okay, both we shall write. The density function fx of x. So density followed by distribution function. I hope the things are clear. Let me write down the density function first because I have noted the density function. Okay, it is 1 minus e power minus x minus a whole square by b. Um, for x greater than or equal to a. This is the expression for a specific range. This is equal to 0 for x less than a. This is the distribution function. If you recollect the density function expression, let me scroll it down on the
By
left
B.
hand side. Please, any issue, please? Um, no, I could not get the point. Someone responded. If possible, please repeat so that I can try to answer your question, if possible. Okay. See, this is the density function. It is given by 2 by b x minus a times e power minus of x minus a whole square by b. Please try to memorize, okay? Because in interviews, people will be very much interested in testing your understanding. Please try to memorize the thing. Okay. In the previous class recording, I have shown how to get the distribution function from density function. So that part I won't discuss right now. What I discuss is how to compute the median of this random variable described by Rayleigh density function. That is the task to be carried out now. I assume that mm, let let x naught be the median of the random variable. That is what my assumption. Let x naught be the median value. If x naught is the median value, just now we have seen that fx of x naught, what does this mean? It is the probability that random variable capital X takes a value less than or equal to x naught. That should be equal to half. Okay. Let me substitute x naught in this expression for probability distribution function. It is 1 minus e power minus x naught minus a, okay, whole square by b. I need not consider the range over which the function has got 0 value. This is true for x greater than or equal to a. Okay. Now I need to evaluate for x naught. So you take natural log on either side so that we can write x naught in terms of a and b. So taking natural logs on either side, okay. So this is 0, this is minus of minus, okay. That's all. This is equal to natural log of half. How can we write natural log of half? Minus natural log of 2. Is it okay? So it is x minus a whole square by b. This is equal to minus ln 2. Is it okay? Till this point, any questions, please? So x minus a whole square equal to, I can put down another step, equal to minus b times ln 2. Is it fine? Now you see what I am going to do. I will write this as it is right now. Oh, it got shifted down. This is equal to b times log ln 2 log 2 to the base e. Okay. Minus in place of x I should write x naught, right? Because evaluating for x naught. So please correct it x naught. Then here also x naught. Here also x naught.
Sir,
Okay. Please,
sir, we will.
please. Okay.
Sir,
I am listening to you. Please tell me.
sir, sir, minus, sir, ln2 equals to x naught minus a by a whole square by b, sir.
We are
ln2
getting extra
equal to
minus, sir.
Extra minus, sir.
for ln2.
Means both sides minus will be there, sir. Or only
Okay.
or only plus ln2.
No, you consider this.
Yes, sir.
First time. Hmm?
Yes, sir.
This step is right, no?
Yes, sir.
Sir, ln 1 by 2 is minus ln 2. He's saying
Oh,
that.
yes. Where? Yes. I have written, no?
Sir, but here
LHS side
there is
minus of
another
x minus
minus
a
no,
whole square by b.
minus x naught a whole square.
Okay. Okay. This is correct only.
Yes.
This minus ln2 minus ln2 is right.
Yes, sir. On the
What I am doing
LHS
is
side,
right. That is what I felt.
on the LHS side, minus x naught minus a whole square by b, sir.
Minus x naught a whole square by b. Here minus is there.
Sir, in equation 1, we can
Mhm.
send 1 by 2 to LHS. So it will be 1 by 2 equal to
Okay. I please wait. I am not able to write. There is. I do not know the pen is not. Now it is good. Okay. 1 minus e power x minus a whole square x naught. Okay. Equal to half. Now please tell me. Taking natural logarithm on
no,
either
sir.
side.
First send 1 by 2 to LHS and rest to RHS. 1
No, on
minus 1 by
LHS, what is that I get?
sir,
1
1 minus 1 by 2 to LHS. 1 minus 1 by 2 to LHS.
1 minus 1 by 2.
To LHS.
Oh, okay. You did like this. Okay, good.
And rest to RHS. E is to power minus x naught minus a.
Is it okay?
So 1 by 2 equal to this. What will be always.
Half. Oh, okay, right. Now, this is what you are suggesting, right?
Yes, sir.
Okay. So, this becomes b times ln2 equal to x naught minus a whole square, right? Oh, right. X naught minus a whole square. Uh, okay. So x naught equal to, this is what we want finally, a plus p natural log to under root. Is it okay? I hope now the things have become an orderly way. Right? This is what the median of the random variable. Is it okay? Now, till this point it is good. Now what values A can take in this expression? What values B can take? So let us refer to the discussion in the textbook, which says x naught equal to A plus square root of B ln2. Correct. There is no problem. And when you see the distribution function, now I am displaying the distribution function. Just you see the x-axis. Along x-axis for the distribution function, at x equal to A plus under root B by 2, we have a value mark. Is it okay? A plus B by 2 under root. Okay. And it is the value at which the distribution function is taking a value of 0.393. But what is A plus B by 2 under root? It is the value of the random variable at which the density function is taking maximum value. Now you see the density function in figure A. So this Rayleigh density function is taking a maximum value of 0.607 under root 2 by B at that value of x equal to A plus B by 2 under root. Okay. So from this, what is clear is, if I have the density function, the value of x at which the density function takes a maximum value need not be same as the median value of the random variable. So this median is different from the value of x at which the density function is maximum. At which a density function is it clear, please? So please have that understanding. From the given density function, we can always find the value of x at which the density function takes a maximum value, and what is the maximum value of that density function. This we have seen in the previous class recording. And from the distribution function, what is the distribution function value when the density function takes a maximum value? By looking at the density function as our distribution function, what inferences do we take? What values the random variable is taking? In the present case that is being displayed, okay, random variable x is taking values, minimum value of A. And what is the maximum value? It can be any value, infinity. So in the expression for this random variable, what constraints are listed? See the constraints now. For real constants, if you can see the cursor, for real constants, A can take any value from minus infinity to plus infinity. The other constraint is B should be positive. B is positive. This is very important. When B is negative, what will happen? When B is negative, let us come back to the Word file. I am just trying to speak from the Word file. When B is negative, here when B becomes negative, it is square root of minus quantity. It is imaginary. That is to be avoided. See, mathematically, we need to avoid an imaginary median And from this statement that B should always be positive, the idea is if B becomes negative, the median becomes imaginary. So that imaginary is to be avoided. Is it clear? And A can take any value, right from minus infinity to plus infinity. What does it mean? In this density function can be shifted to the left. But the thing is, A plus B by 2 under root should be positive side. B should be positive. Okay. Any questions on this, please? Based on A value, if A is negative, based on A value, B is to be decided to make sure that this is real. Okay. This quantity is real. B always should be positive. This is one observation I want to highlight. Another observation is if B is negative, see, I need not calculate median to conclude about whether B should be positive or negative. From the expression itself, let me see. If B is negative, what will happen to the expression? If B is negative, please see the expression for the density function. Cursor I am moving along the expression. If B is negative, e power x minus a whole square by a constant I am getting. It is e power x. E power x is a exponentially increasing function of x. If it is an exponentially increasing function of x, see, what does it mean? When x equal to 0, it is 1. I am getting the case of e power x. E power x means it is a exponentially increasing function of x. When it is exponentially increasing function of x, it is not a converging function. If it is not a converging function, the area under that function cannot be unity. So what does it mean? It cannot be unity. So it cannot be a valid density function. So this is not a valid density function, right? So from the expression for the density function, B should be positive. Is it okay? And A can be any value right from minus infinity to plus infinity. There is no restriction on A value. Suppose A is negative. Please have a look into this density function, probability density function. If A is negative, it becomes 2 by B, x plus constant, e power minus of x plus a whole square by B. That is what the density function when A is negative. Let me write down when A equal to negative. So how do I write that to density function? 2 by B x plus a e power minus x plus a whole square by B. So when you see or plot this expression, it is an exponential e power minus x square, e power k times e power minus k times x square. Okay. So it is exponentially falling function of x. It is scaled by this quantity. So definitely it is a converging function of x. When I have a converging function of x, then only there is the possibility of random density function area becoming unity. If I have a diverging function of the independent variable, then there is no possibility of having total area under the density function as one. I hope the message is clear. Any questions, please? That is how, if you have any doubt, you can always cross check with basics. Any questions till now, please? Let me ask. Aditya is online. So that is calculation of the median of Rayleigh density function. Then the next thing is,
Sir,
please. Any questions,
Sir,
please?
sir, for discrete elements, how it is means for discrete distribution, how it is defined, sir, median.
Okay. So the question is, okay, what I thought was, I thought of covering the continuous random variable case, then going back to the discrete anyway.
Okay.
After really random variable case, we need to consider exponential random variable case, followed by uniform. One more I forgot. Yes, Gaussian. Okay. These all come under continuous random variable case. So for all these cases, you follow the same logic, same procedure.
Yes, sir.
When it comes to discrete random variable, how to find the median value? Okay, we need to write down the expression for discrete random variable, probability density function. Okay. There are two density functions we discussed. One is binomial density function. The other one is Poisson density function. With reference to um, binomial density function, let me write down for the case of binomial. What is the density function? It is always delta of x minus k. What are the strengths of each impulse? If you remember, please correct this. N minus k sigma k is running from what is the upper limit, please?
And
Nk. Okay, k is running from 0 to infinity. I did not remember the upper limit. Okay.
It's N, sir.
Then n. Okay. What is the reason to have n? Any idea? Is it right now? If k is greater than n, what does it mean physically? You have repeated n times the experiment, and you are expecting the desired event to happen more than n times, which is impossible, right? And k should be 0 minimum, because I have the case of happening 0 times a desired event. I don't have the case of desired event happening negative number of times. Okay, thank you for highlighting. Okay, like that, please try to logically conclude. Okay, if you forget something, no problem, but logically try to conclude. Okay, coming back to our friend's question, how to find the median value for a discrete random variable case. So for binomial random variable case, this is what the expression for x minus k. Okay. Let x not be the median value. What does it mean? If I say x naught is the median value, fx of x naught equal to half, isn't it? So if I substitute in probability distribution function 1 minus p u of x minus x naught. Now, okay, in place of k, I am writing x naught. If I write in place of k x naught, what value should k take place? It should be simply can I write down like this? K equal to 0 to x naught n k p power k 1 minus p power k u of x minus x naught. Is it okay? Now, what are the things we need to consider? N0, that is one thing. P power 0, 1 minus p raised to power n minus k, right? So, n over here, that's all. That is one contribution. Second contribution is n1, k equal to 1, p power 1, 1 minus p whole power n minus 1. Like that, up to what value should I continue? Up to x naught, p raised to power x naught, 1 minus p, n minus x. Okay. Now it appears as though we are unable to find the numerical value, but once the values for n, a value for x naught is specified, okay, x naught is to be computed, right? And this total summation should be equal to half, isn't it? When you take this total summation to be half, so we need to compute x naught value. This is how we need to find. Did I answer the question? It may not be so compact as the case of a continuous random variable, but for discrete random variable, we need to go through all the possible steps. Am I clear, please?
Sir, I have doubt again. Means
Mm.
if we don't have 1/2 in the means f of x means like sir, in the case of page number 55, B diagram, sir.
65. Which diagram
Page
is
number
being referred to?
55, sir. 55, sir. 55.
5. Okay. Okay. Uh, okay. 55. No, just tell me the name of the random variable because I try to understand. Which
Sir,
random variable are you referring to?
sir, same binomial distribution only, sir.
Binomial. Okay. Let me refer to that page. See, 55. So, what is the problem? Please tell me.
Sir, 0.5, sir, means half we don't have in like
Oh, okay. Okay. What is this page number? 55.
sir, section 2.5, sir.
Yeah. Thank you. Thank you. Two 2.5, right? Section 2. Okay. I am coming close to that.
Yes, sir.
Okay. This is
Uh,
page 55.
sir,
Okay.
sir, in B
Yes.
class, sir.
We don't have point 2, right?
0.5, sir. Yes, sir.
Okay. N along x-axis we will have only 0, 1, 2, 3. There is no possibility of having values different from that. But when it comes to distribution function, no. See, the idea of 0.5 is okay. Okay, that means let me draw that figure. Yes, here I am trying to plot the distribution function. Below this, okay, x is along x-axis. Along y-axis, we have numericals like this. So at some value x naught, it should be something like this. Is it okay?
Yes, sir.
You are also convinced, right? Up to this spread is vertical spread is half. Vertical spread beyond x naught is also half. Okay. Okay. And your question is, in the textbook figure 2.5-1, there is no value of x for which the distribution function is taking exactly 0.5. Am I
Yes,
right?
sir.
That is what you are
Yes, sir.
highlighting.
Yes, sir.
Okay. In that case, how to define the median value? Anyone can suggest the answer for this? Median value should be computed for a given experiment. That's all. So, for the experiment given in figure 2.5-1, what should be the median value? So, in the figure 2.51, at x equal to 1, slightly greater than 1, the probability has become 0.53. Slightly less than 1, it is 0.1780. So, how to compute the median value? Right now, I don't have the answer. If someone can give the answer, that would be very nice. Who will give the answer, please? Who asked the question?
Sir, Madhu, sir.
Madhu. Okay. Thank you, Madhu, for raising a good question.
Sir, another doubt also, sir.
Yeah,
Sir,
please wait. Let me write down. What is x naught? Okay. Figure 2.5-1. Please, next question, please.
Sir, in the upper diagram, sir. Now we drawn sir, that one.
Oh.
Just now. Sir. Yes, sir. In that 1/2, we have many values of x possible, sir. Means which value we can take, sir.
Okay, there is another constraint, right? Yes. Actually, yes, correct. Okay. Which value of x corresponds to x naught in the previous figure? Is it true?
Yes, sir.
This is what to be answered. Okay. Anyone can answer in the class, please? See, if you have solution, give the solution. I will also feel happy. This is a keen observation, right? So, correct. Does it mean that we cannot have uh, median value for discrete random variable? What could be the other possibility? Anyway, okay. So I will try to answer tomorrow, probably. Madhu, okay? I think it's
Yes, sir.
time to leave.
Excuse me, sir.
Please, any question?
Yes, sir. So I'm also having a little doubt. So in word file, so you
Which file?
solved the so you replaced k by x naught. So why?
No. Please repeat which
So
with
you
reference to
replaced
what?
the last question where you solved. You replaced k by x naught.
Last? No.
So last question which you solved, the binomial case.
Binomial case.
Yes, sir. So you replaced k by x naught.
K by x.
X naught. K by x naught.
Where?
So you replaced k by x naught.
K by x naught did I write? U x minus x naught I wrote.
Yes, sir. So k is replaced by x naught.
Oh, K is replaced by x naught, correct.
Yes, sir. Why?
Ah.
Means x should be replaced by x naught now.
X should be replaced by?
X naught.
Oh, no. See, the idea is along x-axis we plot the values of the random variable, right? Is it clear? So
Yes.
for a random variable, we represent random variable by capital X, values by small x. I am interested in that value of the random variable for which the probability sum of all the probabilities up to that is half. X naught is the value of the random variable. And by replacing here u of x minus x naught, if I write, what does it mean? Value of the probability distribution function up to x equal to x naught. Okay. U of x minus x naught versus what should I write in your viewpoint? U of x naught minus k. Is it true?
Yes, sir.
Okay. So in this expression, what is the independent variable? In this case, independent variable is x. In this case, what is the independent variable? Both are constants, no? X naught is a constant, k is also a constant. So in this expression, independent variable is missing. But here independent variable is there. Am I clear?
Yes, sir. Now it's clear.
No, now it is fine. And in the expression, we need to consider this step function, this up to x naught. That is what my interest is. Say prior to that, you call it as x minus 2, x minus 1, like that. And distribution function is always summation of all these contributions. Is it fine? Any other question, please? Okay. If there are no questions, let me close the session. Thank you for staying with me. Okay, I am closing the session now. Okay, thank you for staying with me so long for 1 hour. Okay.